The timeline of digital human development, from fiction to reality. Digital humans, entities that emulate human characteristics through computational means, have long captured human imagination. From early myths to modern science fiction, the allure of artificial life has been a persistent theme. This paper explores the journey of digital human development, tracing its roots from literary origins to contemporary technological advancements. The purpose is to examine how ideas that once resided in fiction have gradually materialized into reality, reshaping the interaction between humans and machines. The concept of creating life through artificial means dates back to Mary Shelley's Frankenstein in 1818, where a scientist brings a creature to life using unorthodox methods. This novel set the stage for exploring themes of artificial beings and the ethical implications of creation. In the early 20th century, literature introduced robotic and artificial intelligence concepts, notably in Karel Čapek's play Allure, Rossum's Universal Robots, in 1920, which coined the term robot. These narratives reflected societal hopes and anxieties about technology, influencing future technological aspirations by envisioning machines that could think and act like humans. The invention of the first electronic computers in the mid-20th century marked a significant milestone. Machines like ENIAC and Colossus were initially designed for complex calculations. Alan Turing, a pivotal figure in computer science, introduced the concept of computability in the Turing machine, providing a mathematical model for computation. In 1950, Turing proposed the Turing test in his paper Computing Machinery and Intelligence, which questioned whether machines could exhibit intelligent behavior indistinguishable from that of a human. This idea laid the groundwork for artificial intelligence, AI, research. The Dartmouth Conference in 1956 is often cited as the birth of AI as a field of study. Researchers like John McCarthy, Marvin Minsky, and Alan Newell aimed to explore the possibility of creating machines that could simulate human intelligence. Early AI programs emerged, such as the Logic Theorist by Newell and Simon, which proved mathematical theorems, and ELIZA by Joseph Weizenbaum, an early natural language processing program simulating conversation. These initial efforts sought to replicate human thought processes but faced challenges due to limited computational power and understanding of human cognition. Expert systems became prominent in the 1970s and 1980s, aiming to emulate the decision-making abilities of human experts in specific domains. They utilized knowledge bases and rule-based reasoning to solve complex problems. Notable examples include Mycin, developed for medical diagnosis of bacterial infections, and Dendral, used for chemical analysis. While expert systems achieved success in narrow fields, they struggled with knowledge representation and lacked the ability to learn from new data, limiting their adaptability. The 1990s witnessed a shift from symbolic AI to data-driven approaches with the evolution of machine learning. Neural networks, inspired by the structure of the human brain, gained attention for their ability to recognize patterns and learn from data. Algorithms improved, and computational power increased, enabling applications such as handwriting recognition and basic image processing. This period marked a departure from attempting to program intelligence explicitly toward enabling machines to learn from experience. The advent of big data analytics and cloud computing in the 2000s significantly impacted AI development. Massive datasets became available, and cloud computing provided scalable computational resources. These advancements allowed AI models to process and analyze vast amounts of information, enhancing their performance and scalability. Industries began leveraging AI for tasks like recommendation systems, fraud detection, and predictive analytics, integrating digital human capabilities into various applications. Improvements in natural language processing, and the proliferation of mobile devices transformed human-computer interaction. Technologies like speech recognition and language translation became more accessible. Virtual assistants, such as Apple's Siri, launched in 2011, and Amazon's Alexa introduced conversational AI to the mainstream, enabling users to interact with digital entities through voice commands. These developments shifted AI from background processes to interactive agents in daily life. Deep learning, a subset of machine learning involving neural networks with multiple layers, revolutionized AI in the 2010s. Breakthroughs in algorithms and increased computational power led to significant achievements in image and speech recognition. In 2016, Google's AlphaGo, powered by deep reinforcement learning, defeated a world champion in the complex game of Go, showcasing AI's advanced capabilities. These milestones demonstrated the potential for AI to tackle tasks previously considered exclusive to human intelligence. Digital humans emerged as realistic avatars and virtual influencers, blending AI with lifelike animations. Entities like Lil Miquela, a virtual influencer created in 2016, gained popularity on social media platforms, interacting with audiences as though they were real individuals. In customer service, digital humans with human-like appearances and conversational abilities began providing personalized assistance. In education and training, they served as tutors and simulated patients, enhancing learning experiences. Augmented reality, AR, and virtual reality, VR, technologies further enhanced digital human interactions by creating immersive environments. Users could engage with digital humans in simulated settings, enabling applications in remote collaboration, training, and entertainment. For instance, VR simulations allowed for safe practice in fields like surgery or aviation, where digital humans could act as patients or co-pilots, providing realistic scenarios without real-world risks. Advancements in brain-computer interface, BCI, technology opened new frontiers in digital human development. BCIs aimed to establish direct communication between the human brain and computers, enabling control of devices through thought alone. Cognitive computing endeavored to replicate human thought processes, with systems like IBM's Watson interpreting and processing vast amounts of data in ways that mimic human reasoning. These technologies hold the potential to enhance human capabilities and create more intuitive interactions with machines. The rise of digital humans brings forth significant ethical and societal considerations. Privacy concerns emerge as digital humans collect and process personal data. Issues of AI bias and fairness become critical, as algorithms may inadvertently perpetuate stereotypes or discrimination if trained on biased datasets. The impact on employment is also a concern, with automation potentially displacing jobs. Establishing regulatory frameworks and ethical guidelines is essential to ensure responsible development and deployment of digital humans, addressing accountability and transparency. Looking ahead, the next decade promises further integration of digital humans into daily life. Advancements in AI could lead to even more realistic and autonomous digital entities. Potential breakthroughs in quantum computing and further development of BCIs may enhance processing capabilities and human-machine integration. The convergence of biological and digital identities raises profound questions about the nature of consciousness, and the definition of being human. The journey from fiction to reality in digital human development reflects humanity's enduring quest to understand and replicate itself through technology. From the early imaginings in literature to the sophisticated AI-driven avatars of today, digital humans have evolved significantly. Their transformative impact on society is evident in various domains, from healthcare to entertainment. Navigating this era responsibly requires careful consideration of ethical implications, ensuring that technological advancements benefit society as a whole while respecting human values.